Thank you very much for your kind introduction, and thank you also very much for this excellent moderation as usual. So this may give me 2 more extra minutes. I don't think so. So the number of our CRC, the Collaborative Research Center, is given by the German Research Foundation, though we can't do anything about that. But we can do something about this really short title of our CRC, Understanding the Mechanisms and Processes of Biological Effects, Transport and Formation from Model to Complex Systems as a Basis for New Solutions. So first of all, I would like to thank all the organizers for making this all possible here. I think it was a really great meeting and a great conference with really fruitful discussion, so thank you for that. And for those you just mentioned that who do not know me, I'm an ecologist by training, and our lively working group is working since 14 years on the topic of microplastics, and as you said, we develop methods to detect microplastics in the environment, in soil, air, and water, and also in biota, and we're looking at the impact of microplastics from the molecular to the ecosystem level. And so we are involved in plenty of national and international projects dealing with environmental and human health, or the impact of environmental and human health of microplastics, but today I will only talk about the CRC. So why did we start a collaborative research center on microplastics? And this is quite nicely depicted here, a problem solver turned into a problem. And as we all know, plastic debris is found all over our globe. And this plastic pollution is a so-called wicked problem that is highly interconnected to the economy, environment, and society. And as we all know, this large plastic debris does not stay large, it disintegrates into microplastics. And as we have heard today, there are several other pathways how microplastics can enter the environment. And as we have already heard this morning, also microplastics are everywhere in our environment, from the deep sea to the atmosphere, from the tropical regions to the Arctic. And those microplastics may be a potential risk to the environment, economy, and society. So the first report on microplastics was already in 1972, but microplastics research started more or less in 2004 when Richard Thompson published this groundbreaking paper, Lost at Sea, Where's All the Plastics? And after 19 years right now of intensive research, a lot of progress is made, of course, but many questions about the effects transport in the environment and the degradation are still largely unresolved. And now the question arises why after almost 20 years of research? And this is predominantly due to the fact that microplastics is not microplastics, not a single compound, because it's a diversity of contaminants consisting of different polymer types with different physical chemical properties, such as surface charge, shape, size, density, and so on. And therefore, it's a really complex topic. And among this diversity of contaminants are, this is the topic of this meeting at the moment, of course, textile fibers, tire abrasion, and also pellets lost in the environment. So, and most of the researchers working with polystyrene spheres, but also, as we could show in our CRC, they look more or less the same, but even supposedly identical microplastic particles differ in their material properties, and this is also affecting the effects those particles have. And arising from this complexity of the topics, also the grand challenges of the microplastics research is arising. And one grand challenge is the topic of biological effects. And this is quite astonishing because most publication, as you can see in this just recently published review paper on microplastics or in microplastics research are published in ecotoxicology. And although most publications are published there, still most groups are using these dispersed polystyrene particles. Most of the groups did not characterize the particles used. They rarely used H particles, and they rarely also used natural particles as control. And one of the biggest challenges is that the characteristics of those microplastic particles are not described. And therefore, one of the major challenges is that the fundamental understanding of the effects as a function of particles' properties is still missing. The same is also true for environmental behavior of microplastics, for the transport in the environment. Also, this is just recently reviewed. Also here, a fundamental understanding of the transport behavior as a function of particle properties is also missing. And the same is also true for the degradation in the environment. And these three major challenges are exactly the project areas of our collaborative research center. And our main goal is to get from the joint knowledge gain or to elucidate the environmental relevant properties which then do harm to the environment. And this is, of course, the basis of, for assessment of the environmental risk, but even more important, to develop novel materials and solutions, because only if we know what is causing the effects, we can develop novel materials without those properties which do harm to the environment. And this is also what I want to highlight here, that we need, plastics in our everyday life, also in the future. But the way we deal with plastics right now, and some of the plastics material, if there is abrasion, are doing harm to the environment, and therefore we need novel solutions. And it's a really complex topic, and all these three areas, biological effects, behavior and migration, and degradation, are closely interconnected. And therefore, to understanding these interrelationships, it needs a high degree of interdisciplinarity. And in our CRC, we have really a strong team working hand in hand together. We have people from physics, chemistry, engineering sciences, biology, math, and geosciences in our CRC working closely together. And we started in 2019, and right now we are really a team speaking also the same language, which is also important. And right now, over 160 scientists from the University of Bayreuth, but also from the partner organizations, as Christina, are involved in our CRC. So I think we are the first center who is integrating ecology and environmental research with polymer and colloid research, and this is really important to find novel solutions for the future. So just coming to some kind of key results, I know I'm running out of time, but I speed up. So one of our key results is that there are effects of plastics in the environment, predominantly, as Frau Ziemann already said, sublethal effects. And they are really induced by the plastic material itself and not by the particle exposure, because we used also natural reference particles, and this is also mandatory for future, or should be mandatory for future tox testing, that natural reference particles are used. And so the effects are predominantly induced by size and morphology, but also by the aging of the particles, and also the additives and residual monomers play a decisive role for the effects we see with microplastic particles. Therefore, a detailed characterization of the physical and chemical properties of the microplastic particles are essential for understanding the effects. The same is also true for behavior and migration. Not too much surprising, when a microplastic particles is in the environment, there is heteroaggregation with other particles, and this also affects environmental behavior. And therefore, the environmental behavior strongly depends also on the particle properties in all environmental matrices, and therefore also there a detailed characterization of the physical and chemical properties is needed. The same is true for degradation. So we have seen, or we've shown degradation mechanisms and models for 3 commodity plastic types. And as you can see here, a lot of nanoparticles are formed. This is especially important for the pellet loss in the environment. So at the moment, we can't detect nanoparticles in environmental samples, but I'm pretty sure there are a lot of nanoparticles if we are able to analyze those. And therefore, our aim for the second phase of the CRC is to move from those model systems to the more complex systems. And our long-term vision is to develop new plastics without negative consequences for the environment. And in the second phase, we also, of course, focus on different polymer shapes, such as fibers are in focus, but also tire wear abrasion is in focus, especially the chemical complexity. And when I go to the talk this morning, we already looked at water-soluble polymers, but also we also looked at paintings. It's not only the polymer which makes problems, but also the other ingredients in those paintings, unfortunately. So it's not only the polymer. And therefore, also when it comes to the effects, and Frau Ziemann, sorry, I have said Saskia, Frau Ziemann said it already before, that those sublethal effects can have effect on the fitness of organisms. And just remember, if you are, for example, stressed by one stressor, you might be more susceptible, for example, to pathogens or parasites. And this is then not a direct acute toxic effect, but it's an ecological effect. And we are predominantly looking at these biological effects and ecological effects. So we also look at biotic interactions, and microplastics, unfortunately, and also large plastic debris has effects on biotic interaction and therefore on the entire ecosystem. And last but not least, we also develop in our CRC novel polymers on the basis of the knowledge we gain from the other working packages. And I think this is the way we should go for the future. And therefore, we think that the complexity of the topic requires a close and well-networked cooperation. We have that at the University of Bayreuth together with the partner organizations in our CRC. And therefore, we have grown up to an interdisciplinary center for microplastics research. We are a nucleus for national and international cooperation, and we are open for collaboration. And I hope we will be pioneer further initiatives and innovation in microplastics research. And with that, I would like to thank the BMBF for funding Plastics in der Umwelt, because we were involved in the Plabis project, and of course the German Research Foundation for funding the CRC. And thank you for your attention, and I hope I'm in time.